Yeah, good day, viewers, and welcome to Mathematics Concept. My name is Ola, and I'm your favorite mathematics educator. So today we shall be looking at additional maths, and I'll be taking you through a series of additional maths question and answer segments. And today we shall be looking at the sequence. Now, sequence in maths is different from sequence in additional maths. Sequence in additional maths is made up of the AP, the arithmetic progression or the linear sequence, then the GP, the geometric progression or the exponential sequence, and the binomial expansion, whether using triangle, Pascal's triangle rather, or using the principles of combination. So we shall be looking at some of those sequences in additional maths. Although that of maths constitute the linear sequence, the exponential sequence, the quadratic sequence, and cubic sequence. But there is no such word as quadratic and cubic sequence in additional maths, Igcse. And that is why I want to take a look at the uniqueness of this sequence in Igcse to be able to see how far we can go at the end of the day. So welcome to sequence and series in additional maths. And today we shall be looking at some of the frequently asked questions in additional mathematics sequence. If you can understand this video or everything in this video, you see that at the end of the day, you'll be able to solve as much question as possible under the sequence and series without going through a lot. So welcome. Now let's start this. We have a geometric progression as the second term of 27p squared and the fifth term of p raised to the power of 5. The common ratio r is such that 0 is less than r, which is less than 1. Find r in terms of p. Now let's look at this as a matter of fact. Now before we go to this question, I would like to introduce you to the concept of the exponential sequence or geometric progression. Now we are made to understand that there is such what's called the nth term of a geometric progression, which is a r raised to the power of what? N minus 1. Your a is the first term. Your r is your common ratio, while your n is called the number of terms. Now, this is the formula for calculating the nth term or the last term of a geometric progression. So as soon as I see question, I will be in a position to talk about all you need to know before solving this problem. Now, a GP has the second term of this. So that means from this nth term, T2 now will now give you AR raised to the power of 2 minus 1, which is what? AR. You make this equation 1. Then the fifth term, which is T5, now give you AR raised to the power of 5 minus 1, which is AR raised to the power of 4. So you make this as equation 2. That means for the second term, we have 27p squared, and that gives you AR. So you can make this 1b if you like. And for the fifth term, we have p raised to the power of 5. Will give you AR raised to the power of 4. You can make this 2b if you like. So we are going to solve this simultaneous equation. But because this is a geometric progression, we are going to be dividing instead of the normal subtraction we have. So that means we have AR raised to the power of 4 over AR. We give you p raised to the power of 5 over 27p squared. So if a cancels a, r raised to the power of 4 over r will give you r raised to the power of 3. And this one goes for this, that's p cubed over 27. So we can see that. So let's continue our solution from here. So if r cubed is still the same thing as p raised to the power of 3 over 27 is 3 raised to the power of 3. And that gives you p over 3, everything raised to the power of 3. So if 3 decides to cancel 3, so what is your common ratio? P over 3. So you can see how to solve question on geometric progression as far as Igcse is concerned. You can see how easy it is. All you need to do is just understand the principles. And as soon as you understand the principle, every other thing becomes secondary. So please permit me to go to the next question as a matter of fact. Now, this is a method or the question on binomial expansion. Now, binomial expansion, we'll talk about two basic terms. We'll talk about binomial expansion using Pascal triangle or binomial expansion using combination. But for this question, I would like us to just go through a general methodology, which is binomial expansion using combination. Now we are made to understand that we should find the term independent of x in this expansion, given that the first three terms of that means this has been expanded already and the first three terms have been obtained. So that means if we expand this now, raised to the power of 6, you are going to be getting 4096 minus 384x plus 15x squared. Now, if you expand this, this is what you are going to get from what we are actually given. Now, we are not made to get the value of this x minus 1 over x everything squared. So that means the whole of this is now 4096 minus 384x plus 15x squared. Then multiply by, if you expand this using binomial expansion, you have x squared plus 1. Sorry, is it plus or minus? That is minus 1. Okay, let me just do it for the benefit of those that are just learning this aspect. What you're going to do is that this x will take the 2, this one takes nothing, plus x will take 1, then this comes, plus x will take nothing, and this comes, this takes 2. And for the Pascal triangle, we have this is now x squared. This we cancel this, that's minus what? Minus 1. But since you are multiplying by 2, that will give you minus 2 plus 1 over x squared. So if you expand this, what do you have? X squared plus 1 over x squared minus 2. So this is what you are going to get. That means we are going to multiply 4096 minus 384x plus 15x squared by the expansion of this, which is still the same thing as x squared plus 1 over x squared minus 2. For those of you who might not understand how I came about this expansion, you can do your normal expansion, which is still the same thing as x minus 1 over x multiplied by x minus 1 over x. This goes for this, it goes for this, why this goes for this, and it goes for this. So x times x is x squared, minus x times 1 over x is 1, minus 1 over x times x is 1, then minus times minus is plus 1 over what? X squared. So that gives you x squared minus 2 plus 1 over x squared. I think you now understand how I got this expansion as a matter of fact, right? So this is what is obtainable as far as this is concerned, right? So now let's multiply. You realize that to get the constant term, because we are looking for the term independent of x, that is constant term. That means this will multiply this for us to get a constant term, and this will also multiply this for us to get a constant term, because this 4096 times minus 2, are you there? That will give you, that's 2. Remember, there's going to be minus there. 2 times 6 is 12. 2 times 9, 18 plus 1 will give you 19. Carry 1. That's 1 minus 8192, right? That is independent of x. And the other one that we can multiply is plus 15x squared multiplied by 1 over x squared. Why is it a constant? Because this x squared cancels this x squared. So you have minus 8192 plus 15. So what is your final answer? Minus 81. Here is going to give you 7. And 8 minus 1 gives you 7. So you can now see how to solve that. So your final answer as far as this is concerned is minus 8177. Gentlemen and ladies, because of our time, I'll see you in the next video, because I don't want any of my video to exceed 10 minutes. So please kindly digest this and solve similar questions on this. Until I see you in the next video, do have a wonderful day, and bye for now.